So my background is mainly in accelerated graphics. That's what I've been doing for the best part of 10 years now, I suppose. The UA Foundation is a non-profit that I set up in 2012, which kind of allows me to develop, oh, my thing's fallen off, develop open source stuff which anyone else can use. So a lot of what I do is commercial work, but the developments actually flow back into the open source stuff that we do so that everyone can use it for themselves as well. So a lot of what I show today is actually stuff that's part of the open source libraries that we've been working on that you can also have a go with if you're so inclined. So I'm going to start off by just sort of giving you a bit of my background so that you've got some context for what I'm on about. Then we'll go through a few various key things that we've been working on. And finally just talk a bit about what we might be doing next week. Now, when talking about my past, I don't want to sort of get too misty-eyed and so on, but I was a Flash developer for my sins. Anyone else? Yeah, no. But it's dead now, you know. The stuff that I did while that was going on sort of is largely fed into the work that I do now. It was mainly through a library called Away3D, which some of you may have heard of if you were in the same space. We did sort of a lot of online 3D work for online games, for Facebook sites, for sort of massive multiplayer sites, and these sorts of things, driving simulators, Facebook chess, of course, and all this kind of stuff. And everything was great until this happened. And it was sort of inevitable. This is what happens when one person has control of proprietary technology. I wanted to sort of talk about the way we've come out of this and what we've been doing since then that is actually leveraging just basic native web stuff, which is much less prone to these kind of problems. Yeah, the first thing we obviously had to do when this happened was a sort of period of consolidation and conversion. Two things kind of helped with us with this in that regard. WebGL, which is the kind of de facto standard for accelerated graphics on the web. It allows you access to the GPU, which is very important these days with things like tablets and mobile devices relying solely on that for their performance, their graphical performance at least. And the other big thing which came to our rescue was TypeScript. Yay, TypeScript. Which at the time that we started was in its 0.81 release, I think, which was absolute hell. But, you know, it's fine now. There was a few little teething problems, but I highly recommend it, and hopefully this will sort of bring you around to that sort of way of thinking as well. Now, the stuff that we've been working on, like I say, a lot of it is open source. The place that you access this is through this URL here. There's a lot of different modules and so on. We've modularized quite a lot of it now. And it basically deals with the nuts and bolts of trying to just basically get stuff animating in an accelerated manner on the web. There's a few demos that you can see if you go to Away.js examples and the kind of stuff that we have here. Let me just see if I set my Wiimote up right. So the kind of, oh, I knew that would happen. So I'm battling with this this headset at the same time. So the kind of thing that we can do is run things much more graphically intensively, but in a manner that's actually fast enough to be rendered on mobile devices as well as standard desktop devices. And I mean, I won't go into this too much detail. It's easily found if you just download the examples. Although I will say a word of caution: always use the dev branch. That's just that's a motto of ours as well as a piece of advice for you. These things are in development, but a lot of the time the dev branch is the safest place to be for some of this while it's going on. So the thing that I really want to focus on here is our sort of foray into vector graphics. As vector graphics are still relatively underrepresented on the web, especially when you want to do any kind of animation. So you can do static stuff, like SVG is pretty good for static images and icons. But if you actually want to start moving things, again, you run into performance problems. And this was something that we wanted to get around because one of the first commercial projects we used Away.js for was a web game called Icicle, which was a pretty successful game. It was released in 2013. It was already converted to iOS, but they had done like a manual conversion, which sounded like hell. So they wanted to come up with something more automated for their Android and Steam releases. So the problem with Icicle, well, it's not a problem. It's a brilliant game. I definitely recommend you have a look if you haven't seen it before. But the challenging thing about it is that it's all vector graphics. Literally everything is vector graphics. The only bitmap is the background. So you've got a lot of sort of things that scale. You've got the guy, Dennis, who's the main character, can be a tiny little blip on screen in one level and a huge thing in another level. So your traditional way of handling things. Of course, there are other libraries out there, like Pixie.js, which do these sorts of things. But the issue is that they're not really vector-based, and they tend to sort of rasterize everything still under the hood. So, of course, if you're doing any animation, that screws with your performance. So the solution to this, which is not a new idea by any means, is tessellation. And you take a bunch of triangles and you render that instead of the actual shape, and you get your performance. And what we did initially with this is we did something that sort of pre-tessellated everything, and then uploaded that to the game. And this is a debug version of that, but you can sort of see what we're after. I'm actually plugged in, yeah. So, so the game is actually, this is a few years old now, so the game is already uploaded and available on the Android and the Steam platforms. But there was a key milestone trying to get to this point where we could actually sort of tessellate everything, save it in a separate file, and then you could actually just bung that at the renderer at runtime, and it was the fastest way to get everything moving. And the final version, I won't bother playing this, but you can see previews of it if you just search online. It's pretty simple to find. So the next project that we did was sort of consolidating that and talking more about generalization of the framework that we'd initially built. Obviously, we're still trying to run things under the hood in pre-tessellated form, but we are also trying to do something that's slightly more configurable, slightly more adaptable. And one of the biggest things with the next project we did was to be able to do 2D and 3D graphics side by side and mix and match the two and not actually have any constrictions about that, which is, again, a huge stumbling block for any kind of web graphics. And we also wanted to try and enhance things like the drawing API, which again is kind of taken as read for most of these sorts of graphics libraries. You expect to have drawing API to be able to do stuff manually in code, but of course you need to be able to tessellate on the fly with something like that. So being able to do that is also a key part of the engine. So the contract that we were working on was called something called Sunflower Learning, and these guys have a bunch of content that is designed for sort of in-school tutorials, sort of like in-classroom tutorials for things like science and technology subjects, so chemistry, physics, that kind of thing. And it's pretty cool stuff. All of it is originally in Director. And they got halfway through Flash porting before finally realizing that was dead as well, and came to us. So I'll just navigate around here briefly. So we've got, for example, all of this is rendered in Away.js now. We've got everything, all of the sort of interface and furniture as well as the actual animation. But the key aspect of this is that you can mix the two. So, for example, if you're talking about this animation of a rotary motor, you can actually sort of manually pan between the 2D and 3D views, and the two seamlessly blend into each other. So you can actually sort of blend directly into the 2D view, or just go back to the 3D view. And of course, this is something that, again, was pretty hard to do any other way other than actually build it ourselves. So we built this into Away.js. You can also, if I set up the options right, so this is working the opposite way now. So you're now a generator generating current rather than just a motor generating motion. If I switch to the oscilloscope view, we've actually got a layer within a layer within a layer now. So you've got the 2D view, inside which a 3D view is, inside which another 2D view is viewing the little sort of blip on the output there, which is a 2D bitmap that's updating with an output from the motor. So it becomes a lot more flexible to be able to work like this inside the away.js framework, be able to just sort of have your view set up arbitrarily and be able to render one into the other and be able to actually do a lot of this stuff without having to worry about what's going on under the hood. I'll just show you one more of these. So this was another pretty interesting one in terms of like combining graphics. You have a lot of little simulations. You can turn on things like force and acceleration buttons to be able to see things as how they progress in real time, and being able to change the apparatus as well. So, for example, we can change this to like a track. So again, we've got the 3D view inside the 2D view, but then things like the arrows, and we can also have like labels are all superimposed on top of the 3D view and are using projection to map back to the 2D context. Again, all part of the engine, and something that you don't actually need to worry about. You can just sort of create a context, set up its positional information, and then have that project back into a different context if you need the data for the position and so on. And so the third thing, and the thing we've been doing most recently, is kind of optimizing all of this. Initially, as I said, we started out trying to do stuff pre-runtime and sort of converting everything, and then sort of optimizing it, optimizing in the conversion before actually running it. But the next project uses something which was kind of underappreciated, I think, but in many ways was sort of had some pieces in it which were really, really useful. So Shumway is Mozilla's little project that was trying to emulate the Flash player a while back. They had a sort of weird idea about having it as part of the Mozilla platform, and then unceremoniously dropped it, and I'm not sure what happened there. But either way, the code is still available online, and it's all open source. But what we took from this was the AVM code, which is essentially a runtime for the code that's actually compiled within a Swift file. And what this allowed us to do was basically create our own Swift runtime. So we've already got all of the other graphical elements that we need to. And of course, don't forget, these are now accelerated graphical elements. The final piece of the puzzle was to tessellate on the fly as well as run the code on the fly. So now what we're doing is we're actually using Swift files as source files, essentially. We're just running them in as if you load a JPEG, essentially. And the away.js engine handles everything else. So what I'm going to do is just go to the first one here. And it's not going to load. All right, I'll do it manually. So, okay. So this is our debug view. We've got the original Flash player on the left-hand side. So if I turn off Flash, this disappears. And on the right-hand side, we've got away.js. And we were using this for a while just to debug what was going on. So now I can sync up the mouse clicks as well. The voice is a little annoying, so I'll just turn that down, sorry. But this is full of like pretty complex animation. So the little piece of chalk basically writes out everything on the chalkboard. And it's not a particularly complex thing to do in an IDE like Adobe Animate, and using the kind of animations that you've got there. But trying to do this any other way would be virtually impossible. So now we're able to just literally take the stuff that's already, the information that's already in that animated file, output it directly to screen without using any plugins at all. And this was all still interactive. So if I remember my maths, then 285 plus 60 is 345. No, 45. Yay! And I get on to the next stage. So again, this is like a learning program for schools. Part of the reason for doing this, for actually building our own runtime, is that there's a lot more content here. The company that's involved in this has got about 1,200 different lessons that are just as complex as this. So converting it by hand would be extremely expensive. And what we allow is for old sort of legacy stuff like this to be essentially resurrected, and at a pretty quick turnaround now that we've actually got the basics in place. So we can actually do this with Away.js without taking into account any of the other stuff that's already available, because all of the old stuff that we put into the original conversion, like the 3D and the shading, the particle animators and all the rest of it you can see in the examples, is still available and still able to be mixed in with this 2D stuff. So we're really excited now that we've got this sort of thing in place, because the next step really is about utilizing this in other areas. And one of the areas that we're really interested in at the moment is VR, because VR sort of still also occupies this sort of 2D/3D space where you have interfaces where you have to control things which are largely 2D. You either have a panel floating in space, or you have something on the floor that you have to interact with, but that's a 2D rendered panel. And yet there's very little available that will actually allow you to do that without going through some sort of proprietary system. There's nothing that's open source really that allows you to do that. So this is where we're hoping we'll be able to take this next and be able to apply the same sort of techniques we've learned with the project that we've been working on in VR. Another thing we're really interested in is being able to speed up other runtimes. So for example, the SVG renderer, if anyone's ever tried to do animation with that, you'll know that only the very simplest things will pass muster in terms of performance if you want to run on mobile devices or any kind of device that's not got a very powerful system. And yet, it's not really rendering anything very complex. Part of the reason is because under the hood, this is still largely software-based. But we can apply the stuff that we've learned to be able to cache a lot of this and render in 2D on the GPU so that you can have vastly more complex animations in this. And so if you couple this with something like D3 or Vue, then you'd be able to create a much more complex and interactive applications in 2D just by using an Away.js renderer. So yeah, that's basically what I've got. And if you want to check anything out, there's the URL there. There's my Twitter handle for any questions. And yeah, thanks very much.
All right, thanks, Rob. We're going to pick up the pace a bit too, because it's getting quite toasty in here. So are there any questions? Okay. One thing with the Flash legacy stuff that you turned into with Away.js into something else, do you think that's also an opportunity to make sure that all the content that was created in Flash and became unavailable on the web to become available again? Is this thing indexable by search engines later on?
Possibly, but the biggest problem with that is that the content also needs to be accessible on new devices, and unfortunately, when those things were written, devices didn't exist. So there's a bit of a problem with potential accessibility later on if you don't have a keyboard or you don't have a mouse. I think if you can get around those problems, then yes, absolutely, you'd be able to run stuff pretty easily using us just as a conduit to be able to play your stuff on whatever system that you've got. Yeah.
How's your excitement level about WebAssembly?
Well, we actually are looking at using WebAssembly for some of our tessellation algorithms, because at the moment we already had an optimized version to allow us to do that on the fly rather than just pre-processed for the last thing that we did. And in the future, WebAssembly could make that process even faster. So then you'd be able to basically have much more complex shapes tessellated on the fly without any performance drop at all. So yeah, it's going to be really useful.
What is one thing that you think people, when they do animation, do very, very wrong to start to get animation slowly? What's the first thing to actually think about?
I think a lot of the time when you're dealing with real-time animation, people like to slap on a lot of effects and post-processing too early. I mean, people are much more are used to the sort of video output style of After Effects, where you literally don't need to worry about stuff. It just renders offline and then you upload it. But if you want to still be able to do interactive storytelling and have sort of compelling game graphics and all the rest of it, then it's a very different discipline to be able to get this running performantly, even with the help of the GPU. But it is possible to get some really sort of interesting and dynamic graphics going with it. So yeah.
It seems like Flash was years ahead when it came to the JavaScript animations of that time. Do you think that the Unity world is years ahead in terms of VR right now, or do you think WebVR has a chance to overtake that quickly?
I think WebVR is really interesting at the moment because you've got the WebXR API, which has only just been, is it XR or NR? I can't remember.
MR.
Yeah, it's something new, which is kind of combining web AR and web VR, and basically taking that on that whole space as a whole, as a sort of single API, which allows you to do much more interesting things with the web browser than you could ever do before. And the issue with VR is also always about being able to access this stuff. A lot of it is siloed in proprietary stores at the moment. If you just had the ability to run it in any browser, of course, that opens the doors for a whole lot of possibilities. So yeah.
Excellent. So you can see you cannot face Rob with any questions, so please ask him a few questions afterwards. And let's move on to the next speaker. So thanks very much, Rob.
Thank you.